Every atom, every star, every single shimmering galaxy out there screams one impossible truth: it shouldn't exist. Not according to the cold, brutal logic of the universe's birth. We are made of matter, solid and undeniable. Yet the Big Bang, that violent crucible of creation, should have left behind nothing but an endless silent void, a cosmic zero. So how did we escape the ultimate annihilation? When the universe was an infant, barely a whisper past its first trillionth of a second old, it was an inferno of pure, unbridled energy. This wasn't just a gentle expansion. It was a cataclysm, a cosmic forge operating at temperatures and densities so extreme they tear apart the very fabric of imagination. The Big Bang was the ultimate particle factory, spitting out fundamental building blocks at speeds and rates that defy comprehension. Every sliver of raw energy condensed, solidified into matter. But here's the cosmic catch: the inescapable, symmetric truth etched into the universe's genetic code from its moment of conception. For every single particle of matter it forged, every proton, every electron, every neutron, it also created its dark twin, its exact opposite, its cosmic doppelganger, antimatter. This isn't some theoretical fantasy. It's a fundamental dictate of physics, proven in particle accelerators and woven into the very equations that govern reality. Energy, when it transforms into mass, must do so in perfectly balanced, symmetrical pairs. A proton born, then an antiproton, must also emerge from the vacuum. Its equal and opposite charge, its mirrored spin. An electron, a positron, its anti-electron right alongside it. It's a pristine, undeniable symmetry, dictated by the universe's most primal laws at its most volatile, blistering moment. Picture a cosmic ledger, meticulously balanced to the last decimal point. Every entry a perfect counterpoint. The universe in its infancy was this ledger, perfectly balanced, precisely equal. And these cosmic twins, these matter-antimatter pairs, they are locked in an eternal, inescapable death dance. The moment a particle of matter encounters its antimatter counterpart, it's not just a collision, it's a total, absolute, no-holds-barred annihilation. They don't bounce off each other, they don't combine into something new. They erase each other with a terrifying, blinding finality, vanishing in a flash of pure energy, leaving behind nothing but sterile photons. Light, yes, but light without purpose, without the ability to build, to structure, to form anything complex. Think of it like a cosmic self-destruct mechanism built into the universe from its very first breath, designed to ensure a perfect, elegant zero, a perfectly clean slate. So, if the Big Bang was a perfectly fair cosmic coin flip, creating precise equal quantities of matter and antimatter, then the universe should be empty. Not just mostly empty, but absolutely empty of anything substantial. Billions upon billions of particles, each meeting its twin, each exploding into light, until the entire cosmos was nothing more than a vast, featureless ocean of radiation, cooling endlessly, with no atoms to build stars, no gravity to sculpt galaxies, no complex chemistry to spark life, just a faint, uniform afterglow, a silent, expanding monument to a perfectly symmetrical, self-erasing creation, a sterile, light-filled tomb, a cosmic desert where the only thing that ever existed was pure, formless energy, forever trapped in an aimless drift. This is the cosmic crime scene. The evidence, the fundamental laws of physics themselves, scream that we should not be here. The universe should have been a graveyard of light, an echo chamber of vanished energy, a perfectly balanced void where nothing could ever coalesce, where the very concept of something was destined for immediate, total erasure. Yet look around. Look at your hand. Look at the distant nebulae, the spiraling arms of galaxies stretching across billions of light years. It's all here. Matter. Solid, persistent, undeniable matter. The very stuff of existence, the greatest cosmic paradox, stares us in the face, demanding an explanation. How did anything survive this perfectly symmetrical, universe-ending annihilation? What cosmic sleight of hand allowed us to escape the ultimate erasure, to become the very fabric of reality instead of just a memory? But the universe, that stubborn, magnificent anomaly, refused to play by its own perfectly symmetrical rules. It cheated, or rather, the rules themselves bent just enough, because amidst that unimaginable, self-annihilating chaos, something utterly, impossibly unexpected happened. A cosmic statistical fluke, a rounding error so infinitesimally small, it defies rational thought. For every billion particles of matter created, and every billion particles of antimatter created, there was, against all odds, one extra particle of matter, one singular excess. Think of it, a cosmic demolition derby on an unimaginable scale. Billions upon billions of identical demolition vehicles, matter and antimatter, charging at each other, programmed for absolute mutual destruction. They smash, they explode, they vaporize in blinding flashes of pure energy, leaving nothing but dust and ghost light. The arena should be empty, a silent testament to perfect erasure. But then as the dust settles, you squint and you see it, a single, solitary, gleaming hubcap left inexplicably behind. Not because it was stronger, not because it was special, but because for every billion pairs that annihilated, there was one extra hubcap with no anti-hubcap to meet its end. That single, impossible leftover hubcap, that is the universe we inhabit. That is the very foundation of reality. That one in a billion cosmic surplus is all that remains. Every galaxy, every star, every planet, every atom in your body, every thought in your mind, it all stems from that infinitesimal, improbable imbalance. Everything you see, feel, and know is the residue of a cosmic cataclysm that almost devoured itself entirely. This wasn't a grand design for matter. This was a cosmic escape by the narrowest of margins, a whisper of substance salvaged from the jaws of absolute oblivion. The universe exists because, in its first searing moments, it managed to produce a surplus so tiny it should be meaningless, yet so profound it underpins everything. But how? How did this cosmic coin flip, designed for perfect symmetry, land on an uneven edge? How did the universe cheat death itself, leaving behind this precious, impossible remnant? And if this mind-bending cosmic escape has you as obsessed as I am, if you crave to unravel more of the universe's impossible secrets, then smash that like button and subscribe. Join our quest. We're just getting started. The question that haunted physicists for decades was this: how do you break perfect symmetry? How do you tilt a cosmic coin that's designed to land perfectly flat? The answer came from a brilliant, audacious Soviet physicist named Andrei Sakharov in 1967. He laid out three fundamental conditions, like a cosmic detective outlining the requirements for the universe to commit the ultimate act of self-preservation. These weren't just theories, they were the precise surgical requirements for the universe to escape its own annihilation. Condition 1. The universe must not play fair. Sakharov called this baryon number violation. Imagine our matter-antimatter twins. Each proton and neutron has a baryon number of +1. Their antimatter counterparts have all 1. In a perfectly fair universe, the total baryon number would always remain 0, or at least constant. For every +1 created, a 1 is also created. They cancel out. But Sakharov proposed that in the extreme conditions of the early universe, there must have been processes, fleeting high-energy interactions that could convert fundamental particles in a way that didn't preserve this balance. Think of it like a cosmic casino where sometimes a player can win money without anyone else losing it. A small, subtle, but crucial deviation from the universal law of conservation. This means that for a brief, furious moment, the universe could create more particles of matter than antimatter without a direct, balancing antiparticle being formed in the same interaction. It's like a tiny cosmic leak, allowing a trickle of matter to escape the annihilation cycle. Condition 2. The universe must be out of balance. This is the C and CP violation condition. C stands for charge conjugation, meaning if you swap every particle with its antiparticle, the laws of physics should look the same. CP adds parity, meaning if you also reflect everything in a mirror, the laws should still be identical. In a perfectly symmetric universe, matter and antimatter would behave exactly the same way, just mirrored. But Sakharov argued that for a matter surplus to exist, The universe had to, at some level, treat matter and antimatter differently. They couldn't be perfect mirror images. Imagine two identical twins, one made of matter, one of antimatter. In a perfectly symmetrical universe, if one throws a ball, the other, mirrored, throws an anti-ball with the exact same probability and trajectory. But if C or CP symmetry is violated, it's like one twin has a slightly stronger arm or a natural tendency to throw the ball a tiny bit more often than their mirrored counterpart. This subtle difference, this inherent unfairness in how matter and antimatter interact, means that their annihilation isn't perfectly symmetrical either. One might decay into different products, or at a slightly different rate, or with a minuscule preference for matter over antimatter in certain particle reactions. It's a crucial, almost imperceptible bias baked into the very fabric of reality. Condition 3, the universe must be changing rapidly. This is the out of thermal equilibrium condition. Imagine a perfectly balanced ecosystem. Predator eats prey, prey reproduces, and everything stays in a stable, unchanging state. If you introduce a slight bias, say, predators can reproduce slightly faster, but the system is in equilibrium, it won't lead to a massive runaway population boom. The excess predators will just die off faster due to lack of food, bringing the system back into balance. For the matter surplus to stick, the universe had to be expanding and cooling so rapidly that the particles couldn't constantly re-establish thermal equilibrium. They couldn't catch up to their symmetrical, annihilating state. Think of it like a conveyor belt moving too fast for the demolition crew to keep up. As matter and antimatter pairs are created and attempt to annihilate, the universe is expanding, stretching, and cooling them apart faster than they can find their perfect matches. This rapid non-equilibrium the universe was ready to play its ultimate trick. With Sakharov's conditions met, the universe was a ticking time bomb, not of destruction, but of an incredibly subtle, yet utterly profound transformation. The stage was set for the greatest cosmic disappearing act, one that would leave behind the very fabric of our existence. Imagine that super hot, dense, rapidly expanding soup of matter and antimatter, a primordial plasma where particles and antiparticles were constantly winking into and out of existence, colliding, annihilating, and then being reborn from the intense energy. But now, with Sakharov's conditions in play, the universe wasn't perfectly balanced. It had a secret, a tiny, almost imperceptible tilt. For every billion pairs, there was that one lonely, unmatched matter particle. As the universe continued its furious expansion, it cooled rapidly. This cooling was the crucial trigger. Below a certain critical temperature, a cosmic threshold, a point of no return, the sheer energy density dropped too low to spontaneously create new matter-antimatter pairs from pure energy. The cosmic particle factory effectively shut down. This was the moment of reckoning. No more new pairs were being born. The existing particles and antiparticles, still zipping around at incredible speeds, were now on a one-way path to annihilation. Billions upon billions of them found their perfect match. A proton met an antiproton. Poof, an electron met a positron. Poof, each collision, a blinding flash of gamma radiation, converting mass back into pure light. The universe became a vast, self-consuming furnace, devouring its own raw materials. It was a cosmic cleanup crew, meticulously sweeping away every last trace of antimatter, along with its corresponding matter twin. This annihilation phase was unimaginably violent, stripping the universe bare, leaving behind an ocean of high-energy photons, the silent, sterile light we discussed earlier. But because of that infinitesimal, 1 in a billion surplus, something miraculous happened. When all the antimatter had found its match and vanished in a blaze of glory, those tiny excess matter particles, the cosmic hubcaps, found themselves utterly alone. They had no antiparticle twins left to annihilate with. They simply remained. Think of it like this. You have a room filled with a billion red balls and a billion blue balls, and one extra red ball. You tell every red ball to find a blue ball and disappear. Chaos erupts. Balls fly everywhere. Pairs vanish in puffs of smoke. When the smoke clears, the room is empty, save for that single, extra red ball. That is the moment our universe was born. This minuscule leftover residue, this statistically improbable survivor, that is the baryonic matter that constitutes everything we observe today. From that sliver of a surplus, the universe began to build. The light, the photons, continued to expand and cool, eventually becoming the cosmic microwave background radiation, the faint, uniform afterglow of the Big Bang, a ghostly whisper of that ancient, annihilating fire. But the matter, the precious, improbable matter, was finally free to coalesce. Gravity, that tireless sculptor, began to work on this scattered, lonely dust. Over eons, it pulled these surviving particles together, first into vast clouds of hydrogen and helium, then into the fiery furnaces of the first stars. Those stars, in turn, became cosmic alchemists, fusing lighter elements into heavier ones: carbon, oxygen, iron. When these stars died, they exploded, scattering their newly forged elements across the void, seeding the next generation of stars and eventually forming planets. And on one such planet, in a quiet spiral arm of a galaxy born from that cosmic surplus, those same elements, those same atoms, assembled themselves into complex structures capable of asking, how did we get here? The universe didn't start with a bang that created everything. It started with a bang that almost destroyed everything. It was a cosmic near miss, a fundamental law bent just enough, a statistical anomaly that became the foundation of all existence. We are the impossible survivors of a cosmic mass extinction event, the precious residue of a universe that, by all rights, should have been nothing but a perfectly symmetrical, perfectly empty void. The first matter wasn't born from the void in a simple act of creation. It was salvaged from the brink of absolute annihilation, a profound act of cosmic defiance against its own fundamental laws. So here we stand, on a tiny blue speck of matter, contemplating our improbable existence. Every molecule in your body, every breath you take, every thought that sparks in your mind is a testament to that one in a billion cosmic gamble, that infinitesimally small, yet infinitely significant surplus that defied annihilation. We are the universe's triumphant, unexpected outcome, a living, breathing paradox. Our reality isn't a preordained masterpiece. It's the miraculous residue of a cosmic cataclysm that, by all accounts, should have left nothing behind. It's a reminder that even in the face of overwhelming odds, even when the fundamental laws scream for perfect symmetry and total erasure, the universe can surprise us with a profound, beautiful asymmetry, a tiny flicker of imbalance that ignites everything. We are the direct descendants of a cosmic escape act, living proof that existence itself is a triumph against the void. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.